All right, today we're going to talk about the length of something. We talked about how to describe the length of something. So, for instance, if I said, let's say that point was J and this point was K, and I don't know, let's put an M right there. It's supposed to be a K. It's kind of weird looking, but what if I said that this was 3 and this was 5, and then I said this, find J, K. That's all I said. What does that mean? What does that mean when there's no little thing over top of it? Find the what of it? The length of it, right. Everybody hear me? We talked about this yesterday, didn't we?
Yes.
Okay, find the length of this line segment, JK. So that's what we're going to do today. We're finding the length. Or sometimes somebody will say find the distance between J and K. So if I wanted to travel this distance, so from here to here, from J to M is 3, and then from M to K is 5. How do I find JK? What do I do to the 3 and the 5? Just add them up. Pretty simple, okay? So that would be 8. So that's finding the distance from one to the other. But let's change this around just a little bit. I always use the example of, like, you're on the highway, you're going down the road, and let's use mile markers to represent this. So let's say you're going down the road and you're at the 20-mile marker, and then you want to go to McDonald's, right? Here's the golden arches. And you want to go to McDonald's, and you see it says, the sign says, okay, McDonald's at exit, let's say 50, exit 50. All right. Usually on these highways, the exit number corresponds to the mileage, right, on the road, right? They show the miles. So we'll say exit 50. So you're at 20. You're driving down the road and it says, okay, there's McDonald's at exit 50, right? Big old sign, or there's a Cracker Barrel or something, some Pizza Hut or something where you want to go, all right? So how did you, if you're here and you are traveling in this direction, how many miles to get to the McDonald's? 30. How'd you get the 30? What math did you do?
Subtract 20 from
You just subtracted. That's right. You went 50 minus 20, didn't you? And you got 30. Or you could do this. You could go 20 minus 50. But what's 20 minus 50? It's negative 30. But really it's the same number though, isn't it? It's the same distance. Just forget the negative. Now, what do we do in math to forget the negative and make it positive? Absolute value. That's right. So I don't want to get too technical on this, but really the distance is actually the absolute value. So it really doesn't matter which number you subtract from which one, as long as your answer comes out what? Comes out positive, okay? So you get a positive either way. So it doesn't matter what order you subtract. Now, if you're like me, I'd rather take the large number minus the small number, so it automatically comes out positive, wouldn't you? All right, so that's what we're going to do. So that's how you find the distance. If I say, find the distance, and this is what we're going to do today. This is what you would do. You would go, you just subtract them, right? 50 minus 20, and that's the distance. Or it's the length of that line segment, isn't it? If you want to consider that highway being a line segment, right? So that would be how you find the distance. You could do the same thing going up and down, right? So let's say you got a map or something and you're looking, and here's the town you want to get to, and here's the town where you're starting from. Let's say you start at 15 and you want to go to, I don't know, mile 25, all right? Even though you're going up and down, isn't it the same exact thing? So how do I find that distance? D equals what? 25. Do we add them together? Minus 15, right, which is 10. So that's the distance. That's the length of that line segment right there. Pretty simple, isn't it? All right. It gets a little bit trickier when you have to do this. Now watch, I'm going to draw a little X and Y axis. You remember this stuff from Algebra 1?
Yeah.
Yeah, and we've done it in here a little bit, haven't we? With the points and all that kind of thing. Let's draw this next line in a different color. What would stand out? Yellow? Let's go yellow. All right, so actually, let's do this. What if I said I had a point, I'll just make this up. Let's say -3, -2. -3, -2. Oh, you know what I should have done? I should have done, that's right. We'll just do this. And, I don't know, let's put it up here. Let's say this is 1, 2, 3, 4. So let's say that's 1, 4. Is that all right? And let's connect them. And I want to find that length. I want to find the distance between those 2 points. Now, this is not just as easy as just subtracting this from this, because now we got ordered pairs, don't we? We're going in 2 directions. We're not just going left and right. We're not just going up and down. We're going in 2 directions. Sean, what do you think? Well, we're not doing midpoint. We're going to do midpoint later, but it's kind of in the same lesson, all right? This is not finding the midpoint. I don't care where the middle is. What have I cared about so far? To get to McDonald's, I want to find the what? The distance. I want to find the distance. Okay, so let's say I'm here and I want to get here, because a map has got this. It's got coordinates like this. I want to start here. I want to end up here. I want to find the distance. So can I just count? 1, 2, 3, 4. I just can't count, do it, can I? Now, if I was going straight up and down, watch. If I was going from here to here, I could just count, couldn't I? 1, 2, 3, 4, 5, 6.
Oh.
Couldn't I? Well, it's close. It's not exactly slope, but it's very close to it. All right. That didn't line up very well, did it?
7, 4.
Well, let me do this. Let me scooch this over so it actually goes through. Okay, so I can be a little more accurate. All right. So let's count. So you're up here at 4, aren't you? Did you see that? And where you? What's the lowest point right here? It's -2. How far is it from 4 to -2? You could count, couldn't you? So let's count. 1, 2, 3, 4, 5, 6. But let's say we had a big old graph, and we're up at like 172, and we're down to like -348. Do you want to sit there and count all those numbers all the way down? No. There's got to be a better way. So instead of sitting there and counting, if we're at 4 right here and we're -2 right here, remember what we said to find the distance? What do? Remember, if you're at 50 and 20, what'd you do? You subtracted, didn't you? It's the same thing here. So if I wanted to find the length of this purple line right here, I could just count. But if they were really big numbers, that'd be really tough. So a better way to do this, to find this length right here, is to what? Subtract, right? So 4, what? Is it -2? Minus a -2. It's 4 minus, what point are you right here? You're at -2, so you subtract. What's 4 minus -2? It's 6. So what is the length from here to here? It's 6. Is that really helping me find this diagonal length, though? It might. Let's see. Let's see if that's going to help us. What about going across? What if I walked across to right there? How far would that be? Well, where are we here? We're at -3, aren't we? And we're at what? 1 here. Let's count. 1, 2, 3, what? 4. So that length is 4. Would you agree? All right, because we're here underneath of the -3 and we're here underneath of the 1. So that distance right there, if I counted, it would be 1, 2, 3, 4. But I don't always want to rely on counting, because what if that number was -137 and this was +483? Okay, that would be silly to count that many places, wouldn't it? It'd take forever. So what's a better way to do that? -3 what? -1. Okay, so it's -3 minus 1. Now remember we said if we come out with a negative, what do we always do? Just make it positive. So what's -3 minus 1? It's -4, but remember what we do? Put it in absolute value, and it's 4. So what's the length of this line right here?
4.
It's 4. So this is 4, and this is 6. How in the world is that going to help us find the yellow line? Remember, the whole deal is I want to find the yellow line. All right?
Add them together.
So why in the world do we care about this length and this length when we're trying to find that yellow length right there? Any ideas? Well, what did we just form? What kind of a figure did we form? A triangle. Not just any old triangle. It's a right triangle. Okay, you learned this in Algebra 1, didn't you? Okay. Say it. Yeah, I heard somebody say it. Somebody, did you say it? Pythagorean Theorem, right. Okay. Remember doing this in algebra? Pythagorean Theorem. Okay, Pythagorean Theorem, which said what? A squared plus b squared equals c squared. What did the a and the b represent? What lines? There's a bunch of lines here. It's something of the triangle. What about the triangle? The sides of the triangle. Okay, these are the sides of the triangle. The C represents, big fancy geometry word. We haven't said it yet this year, but you learned it in Algebra 1. What is it, Sean? The hypotenuse. That's right. Okay, it's the hypotenuse. All right, so the C represents the hypotenuse. So what are we trying to find here? We're trying to find this distance, aren't we? So let's call that D for distance. Now, what do we know? We know the two sides, don't we? We know this is 4, and we know this is, what? 6. It doesn't matter which one's A and B. And the C is going to be this D for distance. So let's write it out. It's going to be 4 squared plus what? 6 squared equals D. Right, I don't know it. You could call it C, but I call it D. Why did I call it D? Distance, right. And I square it. Now watch. This is what I want you to do. I want you to just add them up, or not add them up, but multiply them and then add them up. So 4 squared is 16. 6 squared is 36 equals D squared. Let's add them up. What's that? 52 equals D squared. I don't leave it like this. I want to get D by itself. Do you remember how to do this? No, you're not going to divide. No, you're not going to divide by D. No. I don't think I've heard it yet. So unsquare it? Is that what you said? Yeah, it's not officially how we say it. I think I know what you're saying. Square root. Right. We take the square root. The square root gets rid of the square. Okay, it's kind of like unsquaring it. I understand what you're saying when you say that, but that's not really an official way to say it. We'll take the square root of it. So you take the square root of this, the square root of this. And you can just leave, if you want to, you can just leave your answer just like that. Or if you wanted to, you could do what to it? Put it into a calculator. Okay, you can put it into a calculator, and that's probably like 7 point something, right? Who's got a calculator handy? Anybody have one? I have one on the computer, but I'm not going to bring it up. Anyway, it's 7 point something. To tell you the truth, I'd be fine if you just left your answer just like that. Now, the book may write it as a decimal. I'm not really sure. So, Elena, what'd you get? Square root of 52. Hit 52, then square root. 7.2. All right. That's good enough. One decimal place is good enough. So you could write it 7.2 or square root of 52. All right. Either way, it's perfectly fine with me. Does that make sense? Now, this is one way you could do it. But look, that's kind of a pain, isn't it? Drawing all that out. You got to draw the x and y axis, and you got to do all this stuff right here. But watch. I wanted to do this so you can see where this formula comes from. I really thought before I taught this that I might just say, here's the formula, just memorize how to do it. But I hate doing that. It bothers me when other teachers do that. I want you to understand where this comes from. And this formula that I'm going to show you here in a second comes from where? The what? The Pythagorean Theorem. All right? It's a squared plus b squared equals c squared. So what I want to do is this. Do you see what we did right here? I subtracted what? 4 and negative 2. Look at my 2 points. I had 1, 4. And I also had negative 3, negative 2. Which ones did we subtract? This is x and this is y, isn't it? And this one is x and this is y. So I subtracted the y's from each other, didn't I, to get the 6. Everybody see that? What did I subtract from each other to get the 4? The x's. You see, everybody see that? And then I stuck it into the Pythagorean Theorem. So watch what we're going to do. I'm going to call... Let's go different color so it stands out. It's ugly green. All right, so watch. What I'm going to do, here's the distance formula. So distance squared. It's kind of like Pythagorean Theorem. All right? Would you agree that looks very close to the Pythagorean Theorem? That's kind of like the C. This would be the A, and this would be the B. But how do I find that A? How did I find this distance? What did I do? I subtracted what? Right, the x's, you can do it either way, it doesn't matter. I subtracted either the x's from each other to get this length, and I subtracted the y's from each other to get this length. So that's what we're going to do. But instead of just saying x minus x, this is what we do. We say x1 minus x2. That just means take one of the x's, subtract the other x from it. See that? That got us our distance. That got us our distance. And then what did we do to that distance? We squared it. Get it? Now, how did we find the y distance? Yeah, and it doesn't matter which order you subtract. Remember, as long as we make it positive, doesn't matter at all. So y1 minus y2, and we square that. So look at this is. This is our distance formula, but this is all taken from the Pythagorean Theorem. Does that make sense? All right. Now, this is kind of a nice way to write it. In fact, if you wanted to put it in a little box, that's fine. But let me show you how they would write it in the book. There's a lot of talking going on, and I'm not finished yet. Thank you. Look at this. This is how they write it. Now, writing it this way, the second way I'm going to write it, makes it look a little uglier, but it's really not that big of a deal. If I want to get d by itself, what did we do over here to get rid of that squared? We took the square root. So watch what we do. We take the square root of all of this stuff right here. Right? So I got one parentheses and I square it.
That way.
You could do it either way, but eventually you're still going to have to take the square root anyway, right?
Yeah.
But I'm just showing you this because in the book, if you look in the book, this is how they're going to write the distance formula. This kind of looks a little nicer because it doesn't have that big old ugly square root there. But either way is perfectly fine. So what do we do to find the distance of the x's? You just subtract the x's from each other. Oops, that's a 2. And then how do we find the length of the y's? We subtract the y's from each other, right? It's like going to McDonald's. How do we get to McDonald's? If we're at the 20-mile marker, we got to get to the 50. What do? We subtract, right? That's how you find the length of the horizontal. This is how you find the length of the vertical, right? Why do you square them and add them up? Because you got to put them into Pythagorean Theorem. Why did we use Pythagorean Theorem? Because what kind of a triangle do we have? A right triangle, and that's how we can solve for a missing side of a right triangle. Aren't you glad you learned that in Algebra 1, Pythagorean Theorem? Okay, so you learned it in 7th grade. Wow, good. Yes? Yeah, this is only right triangles. We always go horizontal and we go vertical, so we always make this a right triangle. Yeah, on all these. Okay, so there's our formula. Now, let's do an example real quick here. Got a few minutes left. Let's do an example using this without drawing out the graph. You don't have to draw a graph for this. You can just plug it into the formula. Let's just make up a number. Let's say 5, -1, and I'm just making this off the top of my head. Let's say -2, 4. Is that all right? Keep the numbers pretty easy. And what's it going to say? The question's going to say, find the what?
Distance.
Distance. That's right. Find the distance. Or sometimes they'll say, find the what of the line segment? The distance or the... No, not slope. We're not doing slope. The distance or the how long it is. What word do we use for how long it is? The length. Right. So they might say, find the length of it. All right, but most of the time I think they'll say find the distance. So we use a distance formula. Let's write down the distance formula. I know it's probably already on your notes, but it's off the screen here, so let's just remember it. Big old square root, right? This is what I always do. I always do it like this, because that looks like Pythagorean Theorem. I'm familiar with that. How do I find the distance of the x's? I just subtract them. See how easy that is? How do I find the length of the y's? I just subtract them. There's the distance formula. It looks real crazy and it looks complicated at first, but it's actually pretty easy if you understand where it came from. Would you agree with that?
Yeah.
Okay, it came from Pythagorean Theorem. So let's plug the stuff in. So distance equals, put the big old square root. Now we're actually going to put real numbers into this. I just wrote this down just to remind us what the distance formula was. Okay, so let's put some numbers in. So what's this say to do? Subtract the x's. So which ones are the x's? The 5, the first ones, right, good. The 5 and the -2. So watch very carefully. It's not just 5 minus 2. What is it? 5 minus -2. That's right. It's very important. Okay, let's do the y's. Which ones are the y's? -1 and 4. So let's do that. -1 what? Minus 4. And now we work it out. It's really not that hard. Don't forget the square root. What's in here? 5 minus negative. What's minus a negative? It's plus, so that's 7 squared, isn't it? What's this? -1 minus 4, which is -5. Now look, if I square a negative, it's always going to come out positive. So it doesn't even matter if it comes out negative or not in here. So I'm just going to put a 5 and square it. Remember that, right? Add a line, change sign. -5. Remember, it doesn't matter if it's negative or positive. I'm just going to make it positive squared. What's this going to be? That's 49 plus what? 25. We're almost done. This is what? 74. I would just keep your answer just like that. If you really wanted to, you could put it into a calculator and get a decimal answer. Let me give you a worksheet before you go, and then what we're doing is we're not doing the whole thing. We're just doing 1 through 12, all right? And it's section 1-3 worksheet. We're only doing 1 through 12, not the whole thing.